Problem number 43. A 4 kilogram particle moves from the origin to a position C, having coordinates 5x is equal to 5, y is equal to 5. Now, one force on the particle is the gravitational force acting on the negative y direction. Using the equation, calculate the work done by gravitational force on the particle as it goes from origin O to a C. We have to go in part A along the purple path, part B along the red path, and a blue path. In the D, your results should be all be identical. Why? Okay. So let me draw the picture. So we have a coordinate system. This is y. This is our x. Suppose, okay, this is, say it's 5. Say this is 5, okay. This is our point C. Now, in the first case, probably we might move from origin, okay. In part B, we might be moving from like this one, okay. Then finally we might be moving along the diagonal, okay. So how can we solve this problem then? What are the values are given here? The mass is given, so the mass is given, which is 4 kilogram, right? We have to calculate, so there's only one force which is acting on the object, which means that's on the negative y, which is our Fg, okay. I have to calculate gravitational force. So gravitational force. Okay, so we have to calculate work done by gravitational force in different paths. So first of all, let's do calculation using the green path. Okay, so we know that gravitational work done by gravitational force is equal Fg times a distance multiplied to the angle between them, which is cosine theta, right? Now, first of all, let's use the green path, which is if we want to go from point O to point A and from A to C, right? So that means we can say that it's equal to work done by gravitational, that it's going from O to A, plus work done by gravitation from A to C, which means Fg will be mg, right? Multiply the distance will be 5 meters. And what will be the angle between them? Now the angle between them in this case, as you can see, is 90 degrees, right? So that means if it's 90 degree, we can say that it will be cosine 90 degree, right? If you then what we have then plus the work done by gravitation along the AC, and that will be mg multiplied 5 meters, the distance, and the angle between them will be cosine. So as you can see here, our Fg is pointing downwards and our path is upwards, so the angle between them is 180 degree, multiplied 180 degree. Now let's do calculation. The mass is equal to 4, so this mg will give you, okay, 4 multiplied 9.8 multiplied cosine 90 degree, then plus mass 4 kilogram multiplied 9.8 multiplied 5 multiplied cosine 180, right? Let me check. Here we have 5 multiplied. So we got here, which is equal to work done between OAC is equal to minus 196 joules. Okay. Now this is now let's calculate what will be the work done by gravitation along the paths O, B, and C. Okay. So this is the second part. Work done by gravitation along the O, B, C, which is equal to mg multiplied distance is 5 meters and multiplied the angle between them. Now as you can see here, the angle between them is 180 degrees, which means cosine 180 degrees, right? Then plus mg times 5 meters, which is a distance, and this time angle between them, this is our fg and this is our distance d, so this one is 90 degree. That means we have to put cosine 90 degree. Now if you do calculation, you will find that it's equal to the same as 196 joules. Okay, then finally let's calculate what is the work done by gravitation by moving between O, C. Okay, which means mg, what will be the distance here? The distance is obviously, you have to use Pythagorean theorem, which is 5 squared, right, plus 5 squared, and cosine. Now this time, what is the angle between, this is our FG, right, and this is our angle, which is 45 degree, and this is our distance, correct? This is 45 degree, this is 90 degrees, so total will give you 135 degrees, 135 degrees. So that means cosine 135 degrees. So let's do calculation and see what we can get. So the mass is 4 kilogram multiplied 9.8 multiplied the square root of 5 squared plus 5 squared, then multiplied cosine 135 degrees. Okay, 5 squared. So cosine 135 degrees, which means this is 5, right? So again, you should get that it is equal to minus 169 joules. Now as you can see that by moving either along the OBC or OAC or OC, we get the same the potential energy, or sorry, the work done by gravitational force, which were the same. Why? Because the gravitational force is conservative, so it doesn't depend on the past, so it only depends from the origin and the final positions. Even if you, for instance, measure the potential energy going like this up to here, you will get the same gravitational potential energy, or work done by gravitational potential energy.